Okay, now let's start. This is the presentation of the EEL682 file project. My name is Mingyang Liu and my project is to design the image recognition system. So first, let's look at the problem we need to solve. What a basic image recognition system is composed of? What functions is required in this kind of system? I think there are basic two functions we need. The first one is for a random image picture, the system can locate the image and the pupil area and identify the boundaries. The second one is that after locating this image, the system can also recognize the spatial characteristic of the image and then identify if two image pictures are from the same eye. Let's take this as an example. First, this is a picture of the image, and the white circles locate the borders of the pupil and the image. And then, if we have another picture, this system can determine that if the two pictures are from the same eye. So after we know the problem we need to solve, then we should know that how to solve this problem. And the basic image recognition system, the basic problem can be separated to subproblems. The first one is iris locating. The second one is iris recognition. The second problem can also be separated to three subproblems. The first one is iris normalization. The second one is that after normalizing the picture, we extract the feathers from the picture. And then we get the feather and we compare the feathers from two pictures and we find the differences from the feathers and use this to determine that if the two pictures are from the same eye. So let's look at the part one, how to identify the iris area boundaries. There are already several existing approaches which can solve this problem. Such as the famous Dogman method, the Wells method, the Cameras and the Wells method, and so on. So these methods have been proved and have been used in practice. I just choose one of them, the famous Cameras and the Wells method, to do the locating. The basic idea of the Cameras and the Wells method is just as shown in this formula. The big N refers to the total number of directions. The I delta R is the image intensity with respect to the radius in the polar coordinate system. The G delta R refers to the image derivatives with respect to the radius in the polar coordinate system. Pay attention, all these are in the polar coordinate system. So use this, it is not very hard to locate the area. The program is not very hard, and there are many documents I can look up in the website. But when I doing the code, I found one disadvantage of this algorithm. Let's look at this picture. When we use this algorithm, we must search every pixel in the whole picture. So if we use a picture like this, we can find that all these parts, they are unnecessary, they are useless. Only the part in the square is useful, just as the picture on the right side. But if we use the algorithm directly, it will search all the pixels. This will be a waste of time, which will affect the efficiency of the whole program. So how to solve this? I think about it and do some experiments, and then I come up with an idea to improve this algorithm. If some part in the picture is useless, why not cut off this part? Why not use a close-up picture of iris to replace the original picture, just like the right one to replace the left one? Then it will be more efficiency, isn't it? So I think about it, and then I come up with an improvement code with 2 steps. The first step is that I cut off the useless part and only keep a close-up picture. The second is that after doing this, I use the cameras and wheels method. I use the cameras and wheels method to locate the boundary in new picture. But how to realize it in MATLAB in the code? I do some experiments and finally I found a way to do this. We all know that the center of the iris must be the pupil, and no matter what colors your iris is, you must have a black pupil. So the center of the pupil must be black. It must be the darkest part in the whole picture of the eyes. So if we find out the center of the pupil, we can locate the area of the whole iris. So first we need to find out the center of the pupil. In MATLAB, the image is stored in matrix. A darker pixel has a smaller value and a lighter pixel has a larger value. For example, the white pixel is stored at 255. So if we go through the whole matrix and every time we choose several numbers in the matrix as a group, we calculate the sum of values of this group, and we only keep the group with the smallest sum. Then this group represents the pixels, which must be the darkest part in the picture, which must be the center of the pupil. Like this. If we do this to this picture 1 on the left side, we will get the center of the pupil, which is also the darkest part in the center of this picture on the right side. So after this, if we take this center as the center of the square and we choose a proper size square, we cut this off from the picture, we can just cut off the iris area and leave all the other unnecessary parts away. So since we use the MMU iris database, and I do the experiments and find out that the 150 would be a proper length of the side of the square. So we use this as the center and cut off a square with the length of size equals to 150. Then we will get a close-up picture of the iris. And then we use the algorithm to search this iris picture. It will be faster than the original one. This is the basic idea of my improvement. So after that, let's look at the compare of the two methods. There are obviously two advantages of my method. First one is that it is more efficient, it's more rapid than the original one. The second one is that after cut off the useless part, this method can reduce unnecessary noise factor and make the result more accurate. So after locate the iris area, we need to recognize the iris. The basic recognition of iris is composed of two steps. The first one is image normalize. The second one is template matching. After locating the iris and pupil area, I will normalize the image and generate the template for the image. This template can represent the special feature of one iris. Since different person has different iris spot, the template must be unique to each person. Then we can calculate the Hamming distance between two images using template. If the distance is less than 0.2, it is highly possible that the two images are from the same eye. Otherwise, they are different eyes. So all the content above is the basic idea of my iris recognition system.